All right. So welcome back. I hope that the air test went well yesterday. Today we're going to start Unit 8. So this is our final unit. This is also the rocket project unit, but we will have a mini test. So let's get started here with radicals. This is important to know as we continue in this unit because when you're working with the quadratic formula, you could get a radical answer. So we're going to simplify some radicals. You should have done this last year in Math 8 as well. But a radical, right, is something that looks like this. Okay, it's a radical symbol, and then underneath the radical symbol, you have what's called the radicand. So that is the thing, like if we take the square root of 9, 9 would be called the radicand. Okay, this is the coefficient that's out front. Remember coefficients, just like if it's, 5x, 5 would be the coefficient. So it's being multiplied times x. It's the same case here. You have 5 times the third root of 7. So instead of saying the square root, it's a third root, which means what number times itself 3 times, right, would give you 7. That's what that means, the third root of 7. If it's not shown, so if there's no number here, if there's no index, then it's implied that it's 2. So what that means is you can just assume that it's the square root instead of the third root or fourth root or whatever. Okay, so a couple of definitions here for you. And again, I'm going to try and keep this quick for you today. First one is rational numbers. A rational number is any number that can be expressed as a ratio of p divided by q. So for example, the whole number of 2, okay, can be expressed as a fraction. You just put it over top of 1, 2 over 1, which remember 2 divided by 1 is just 2. So same equivalent number. 3 over 7 is also a rational number because it's expressed as a fraction. Okay, so that means that irrational numbers, and again, feel free to pause this video if you need to copy this down, but irrational numbers are any number that cannot be expressed as a fraction. So for example, the most popular one in all of mathematics is, of course, pi. Pi is written down typically as 3.14, which is a terminating decimal. However, the actual number that represents pi goes on forever and can't be written as a fraction, right? Like you could write pi over 3, but the problem with that is you still have this unlimited number on the top of the fraction, so that would not work. Often students think that 0.33 repeating is an irrational number, but that is not true because 0.33 is the same thing as saying 1/3, right? And so that actually goes up here. So it would not be irrational because it can be expressed as a fraction. Okay. All right. So below here, you can see that we have an index of 2. It's an imaginary 2 in this case. And we complete that. So the square root of 4 is 2. Square root of 9 is 3. It's 4, 5, 6, 7, 8, 9, 10. Square root of 121 is 11. Square root of 144 is 12. 13, 14, and 15. And you're probably asking yourself, why in the world did we just do that? Well, because as you simplify radicals, you must have a perfect square in order to simplify. So a perfect square, you can think of, is the side lengths of a square would make a perfect square. So 2 times 2 gives you 4. So 4 is a perfect square. So the idea behind simplifying radicals is that you're going to look for factors that are perfect squares or use a factor tree, right? So in this first example, in order to simplify radical 12, I know it looks pretty simple as is, we want to break this down. And we want to look at all of these perfect squares, 4, 9, 16, 25, 36, etc., okay? And we're going to identify which is the biggest one, so largest perfect square, okay, that goes into 12. Well, is 12 divisible by 16? No. Is 12 divisible by 9? Not evenly. Is 12 divisible by 4? Yes. So we're going to break this down to radical 4 and radical 3. Because 4 times 3 gives you 12. And then since 4 is a perfect square, we can break it down a little bit further. And that's going to give you just 2, because 2 times 2 gives you 4, right? So the square root of 4 is 2. So that means our simplified version of radical 12 is 2 radical 3. Okay, so again, we're using a factor tree here, breaking it down. All right, same thing here with number 18. You have radical 18. What's the biggest perfect square that goes into it? 16 does not go evenly, so it's got to be 9. So radical 9 over radical 2 gives you 3 radical 2. So this is 3 radical 2. Okay, and again, you know where to put up your final answer once you get to a point where you no longer have any perfect squares. Like if radical 2 had a perfect square that went into it, I would break this down further, right? But I can't, so therefore I'm just left with 3 and radical 2, and you just multiply those back together, and that would actually get you back to the square root of 18. And just to verify that you have the right answer, you could even put it into Desmos. Maybe. It's going to work well. So radical 18, 4.24264, etc. 3 times radical 2, and you can see the answers to both of those are exactly the same. Okay. All right, example 3, 50. What perfect square goes into 50? In this case, 25 is the biggest one that goes into it. So 50 divided by 49. Guys, 49 is a perfect square, not even. How about 50 divided by 36? Still not going to work. 25, though, does work. So, breaks down to radical 25 and radical 2. And then 25 is a perfect square, and that breaks down to 5. So this would be 5 radical 2. That is your simplified radical. So again, hopefully this is kind of ringing a bell from last year. I'm going to kind of speed up here on some of these questions just so you don't have as long of a video. But obviously you can ask Mr. Figgle, you can ask myself, you can pause the video if you need to, and always verify your answers. Okay, 2 radical 80, well that would be 16 and 5. And I'm going to write this one sideways. It's okay if you do the factor tree like we did in the first 3, okay, or if you do it this way. So 2 radical 16 times radical 5. Because 16 times 5 gives you 80, right? And that's equal to 2 times radical 16 simplifies to 4. And radical 5 does not have a perfect square that goes into it. So that's done. And then 2 times 4 is 8. So the answer here, the simplified version, is 8 radical 5. Okay, notice this 2 was dragged over to our answer as well. Okay, 72, well, 72 is divisible by 9. Oops. Okay. But if you think about it, that gives you 8. 8 also has 4 that goes into it. So that tells you that it has a bigger perfect square. So remember I said we're looking for the largest one. So what's a bigger perfect square that goes into 72? How about 36? So radical 36. And radical 2. And radical 36 simplifies to just 6 because it's a perfect square. Radical 2 does not simplify any further, so our simplified version is 6 radical 2. That's how you simplify that radical. Okay, number 6. Ooh, now we have this negative out front, so be careful of that. We're going to bring that down here as well momentarily. Okay, but for right now, 243. Well, 243 divisible by 3 is 81. So radical 81 is a perfect square. And it breaks down to 9. So we have 9 radical 3 that doesn't break down any further, and the negative symbol. So negative 9 radical 3 is equivalent to radical 243. Okay. 4 radical 10. 10 simplifies to 5 and 2, but neither of those are perfect squares, so we can't really simplify that down. It's not like our goal is to bring one of these out front, but since neither of these is a perfect square, they will not come out front. So 4 radical 10 is a case where this is already simplified. Get this out of my way. And that's the answer for that one. And that happens sometimes. Okay. How about 200? Can you think of a perfect square that goes into 200? Right? And again, if you get caught, look up here. Or stuck, I should say. Not caught, but if you get stuck, look up here. 100. 100 goes into 200. Radical 100, radical 2. The square root of 100 is just 10, and radical 2 does not change. So your answer here, 10, radical 2. Okay, and as we practice this, you should be able to get quicker and quicker. All right, so I've got a couple here, 1, 2, 3, 4, 5, 6. I'm going to have Mr. Figgle help you with those, and you know, for 7th and 8th grade, we'll have the substitute teacher, but I will have the answers to those. I want you to go ahead and pause the video. Actually, I'm going to end this video. I want you to go ahead and try those on your own, and then I'll make a second video for the next part of the assignment. Okay? So good luck with the you try, and I'll talk to you in a moment.